Hello everyone, today we are working on the average rate of change, section 2.4 in our books. First question they want us to answer. A function is given. They want us to determine the average rate of change of the function between the two given values of the variable. So they've given us the function f of x equals 7x minus 5. They've given us that the first value of the variable is 3, the second value of the variable is 5. Sometimes they will not even denote this as x1 and x2, they'll just give you the 3 and the 5 and expect you to know that this is the first, this is the second. Something you're going to want to get down in your notes is the average rate of change formula. So you're going to need to know that formula if they're asking for the average rate of change. So the formula is saying f of my second variable, so I actually take my second variable and plug it into my function, just like we've been doing with our function notation, right, with the functions previously, and subtract that by my first variable plugged into my function. I do all of that and divide that simply by my second variable value, which is 5, minus my first variable value, which is 3 in this case. So let me go through the average rate of change formula given this function. So I'm going to plug into the average rate of change formula. So f of x2, well in this case my x2 is 5. Minus f of x1, in this case my x1 is 3. And I divide that by my x2, which is 5, and my x1, which is 3. So now I just go through and solve what my f of 5 would be. So I take the 5, plug it back into my original function, wherever I would see an x. So if I plug 5 in my original function, I get 7 times 5 minus 5. I'm going to put all of that in parentheses, so I realize all of that is my f of x2, right? All of that is this right here. So I'm going to keep that in parentheses so I don't make any small mistakes later. I subtract that by f of 3. So just like the first one, I'm going to put f of 3 all in parentheses. So when I plug a 3 in wherever I see an x, I get 7 times 3. Right? Wherever I see an x, I plug a 3 now, minus 5. And that is all in parentheses, all divided by 5 minus 3, which is 2. Okay, so let me continue on. 7 times 5 is 35, minus 5 is 30, minus 7 times 3 is 21, minus 5 is 16, all divided by 2. So 30 minus 16 is 14, divided by 2 gives me 7. So the average rate of change for this function between these two values is 7. Let's do the next example. Here they've given us the function f of x equals x cubed minus 4x. They first want us to graph the function using a graphing device, and then state approximately the intervals on which f is increasing and on which f is decreasing. So first I'm going to explain what increasing and decreasing means, and then I'll actually go into determining how we can find the intervals on which it's increasing and decreasing. So here I have my graph of f of x equals x cubed minus 4x. I've done it on Desmos already, but I'm also going to show you on your TI-83 so you can see how to do it on your own. I did it on here first just to explain what increasing and decreasing intervals mean. So, let's start with the increasing intervals. Increasing intervals mean we're going up. I like to think of it as I'm going uphill. Right? So I'm increasing, right? I have a positive slope. I'm increasing. So I can see that this graph, right, it goes on forever this way, it goes on forever that way. I'm increasing from way down here all the way till I get to that point. At that point, I'm no longer increasing or decreasing, right? I'm constant. I'm right at that point. So I'm increasing from negative infinity, really from this left value all the way up to this point. And then I stop increasing. But then I'm also increasing from this point here all the way up to those numbers. So I'm increasing on two different intervals. I'm increasing from here to this point, and then from this point on, whatever those points may be, and I'll show you how to find those points in a second. And then I'm decreasing, I'm going downhill only at this interval. Right, so from this point to this point, I'm going downhill, I'm decreasing. So now let me show you how we could find this graph on our TI-83, and then how to find the intervals that are actually increasing and decreasing. Okay, so here we have our TI-83 that we're all familiar with. I'm going to plug in my function to y equals. So when I type in x cubed minus 4x, I get this graph. And that looks very similar to the graph that I did on Desmos. I just did it on Desmos, as I said, so I could explain increasing, decreasing a little bit better. So here on our TI-83, on the graph, right, it looks like this point is somewhere in between -1 and -2, but maybe certainly on the point, or certainly on y equals 3. Right? So, but we don't know exactly what that point is, right? And when we're talking about increasing and decreasing the intervals, we're only talking about the x intervals, so we're not worried about the y intervals. So my x interval is somewhere in between -1 and -2. So to find exactly where my graph stops increasing, I've got to find that maximum point on my graph. So it's hard to see the maximum point from here. So I'm going to go over and find the maximum on my TI-83, then I can determine the intervals where I'm increasing and decreasing. So when I go in my TI-83 to find that maximum point, I click the second button, and then I click the trace button. It's got this little yellow icon above it that says calc. Since this is a peak, a mountain peak, right? It's like a mountain peak. I'm going to think of it as a maximum, so I'm going to find the maximum. To find the maximum, first, the calculator wants the left bound. So I'm going to take that little cursor right there, and I'm going to move it to the left-hand side of my mountain peak, of my maximum. Then it wants a right-hand bound, so I'm going to put that little cursor on the right-hand side of my peak, on the right-hand side of my maximum. And then it wants a guess. So I'm going to get as close to the top as I can, and then enter, and it's going to tell me that maximum point. Okay, and all I'm worried about is the x value there. So you can see it's not even exactly on 3, so I wasn't even exactly correct that it was on 3. This is why, even if it looks like it falls exactly on a point, we're going to go in and find the max and min for these two values every time we do these types of problems. So I can see that this point, right, that point is the point -1.15, and hundredths is far enough, comma 3.08. Okay, so -1.15, and let me write that a little bit bigger so we can see it easier. So -1.15, comma 3.08. That is this point right there. So it's increasing from way down here until I get to the point -1.15. Now I also need to find this minimum here so I can see when I'm increasing and when my decreasing stops. So I can see when my increasing starts and my decreasing stops. So I have to go into my TI-83 now and find the minimum here. So on my TI-83, I'm again going to click second. Second calc, but now I'm finding the minimum. So I go over here, they want a left bound, so I'm going to stay to the left of my valley. I like to think of this one as a valley, that's how I know it's a minimum. Right, so the left of my valley, then I take the cursor, I go to the right of my valley, and then it says guess, so I'm going to go right near the bottom, try to get as close as I can, and now I can see that's a positive 1.15. All right, and a positive, my x is a positive 1.15, and my y is now a negative 3.08. So now I've got my maximum point, I've got my minimum point, so now I can determine the intervals of when I'm increasing and decreasing. Okay, so that was the point there. If we remember, you can go back in the video and check. And then this point was a positive 1.15 and a negative 3.08. Okay, but the y value really doesn't matter anyways. All we're worried about are the x values when we're talking about increasing and decreasing. So increasing, I can just abbreviate it. Increasing. So we are increasing from negative infinity, right? Whatever negative number I can think of, we're going to be increasing. So it starts at negative infinity. And I increase until I get to this point. So I'm increasing from negative infinity all the way to the point negative 1.15. Okay, but that's not the only time that I'm increasing. I'm also increasing from this point to positive infinity. So I'm going to show that. I'm increasing from negative infinity to negative 1.15. I'm also increasing from 1.15 to positive infinity. You'll notice that I have parentheses for both, right? Because at that point, I am no longer increasing. So I do not include that point in my increasing interval. Right, just the same here. I do not include this point on my increasing interval because I'm not actually increasing at that point. At that point, technically, I'm constant. Right, I'm not going up or down. I'm staying the same. So my increasing intervals, negative infinity all the way to negative 1.15, and then I'm also increasing at positive 1.15 to infinity. And like I said, I'm only worried about the x values. Now I also have to determine when I'm decreasing, and I'm just going to abbreviate it like that, I am decreasing from this point here, so from negative 1.15 to a positive 1.15. Okay, so decreasing from this point here, I'm going downhill, if you want to think of it that way, from that point to that point, and again, not including those points, because at those points I'm constant, I'm neither increasing or decreasing. So, when they ask us to find the intervals of increasing and decreasing, we can graph our function, right? Then we got to find any maximum, any minimum, and we're just worried about the x values to determine the intervals of when it's increasing and decreasing. So now I'll go ahead and try the examples that accompany this in the PowerPoint. We'll talk about it beginning of class tomorrow.